Okay, have you worked through them at all?
I got up to 7. It took me a little bit to understand the equation since I keep thinking trig, but it's different.
Okay, I got up to 7. I didn't finish 8. And then I think I have the right answer for 9, and I didn't finish 10.
Okay.
So why don't we go over what we got for the first couple? But I think we're supposed to put all of this in the document too.
It said only one person needs to submit it.
Okay, so like as long as one of us has it written out and we submit it, that should be fine.
Right.
I think it said also like when you submit it, you have to like put who came to the meeting or something like that.
I know there's a participation report, and last week when I submitted mine, it just asked how, like, I personally participated with the group.
This was like link to your group's meeting, names of participants participating in group, name of group members who were unable to attend but contributed, and 4 neatly worked solutions. So I think all we need to do is like take a picture of whoever we decide to turn in, put a link to our thing and our names in it.
Okay.
And it has to be a PDF, I just read. So
yeah, I just saw that too.
It should be open. Okay, so what did you say for number 1?
So number 1, I said by taking 2 different size steps, a person cannot end up at the starting point.
Are you still there?
Hello?
Oh, are you back?
Yeah, was I the one who cut out?
I don't know. It might have been me. Your thing is still black for me, so I can't see you, but it might be me.
Okay, I don't know. We'll try to make it work, right?
Yeah. Okay, so what did you say for the first one?
So the 2 different sizes, the first 2 steps,
Mm-hmm.
it can't work because say you take 2 steps to the right and then 3 steps to the left, you can't get to make the magnitude 0.
I said yes though because I thought like if you took like one step that was like 2 feet and one step that was like 1 foot, and then you took one that was like 1.5 feet and one that was 1.5 feet or something like that, a variation of that, then you would be able to. But I could be wrong on that.
Well, the thing is you have let's see. So you have 2 steps, right?
Mm-hmm.
The first part is 2 steps.
Yep.
Um, and those have to be different sizes.
Yeah.
So it can't be 0 because you'll still.
I thought though if you had equal magnitudes but they were going the opposite direction, it could equal 0. Okay. I thought if you put equal magnitudes but going in the opposite direction, they can equal 0. Are you saying they can't equal 0?
Not with the
Now
vector.
the 2 different sizes.
Yeah,
Okay.
because it'd be heading one direction then the other.
Okay.
But with 3 or more, you can make it into 0.
Okay. Okay. That makes sense. Okay, so for 2, I did the r equals the square root of a squared plus b squared. So I squared 18, added it to the square of 25, and then I took the square root, which gave me 30.8 meters to the northwest. Is that what you got?
That is what I got.
Um, for 3, I did the Vx equals V cosine theta. So it was 6.72 cosine 26.5, which gave me 6.013 or 14. And then I did the same thing for Vy. So 6.72 sine 26.5, which gave me 2.998. And then I did the same thing with the last equation where I squared each of those, added it together and took the square root, which gave me 3.75. Is that what you did?
Well, I did the cosine and sine, but I did with 23, and 23 gave me a different answer.
I thought you had to go from like the x-axis to the like r to the new resultant vector is what I thought you had to do. It gave you a different answer, you said?
When using 23 degrees instead of the 26.5. When I did the 26.5, it gave the answers you just gave.
Yeah.
Um,
Which one do we use? Because I thought you had to take it from the bottom of the x-axis and then to the top to get like the total degrees, but maybe you don't. I don't know. How would you choose between? I don't know. How did you decide to do that?
so this was my logic when trying to know what to do. So let's see. V Okay. So you see on the diagram how there's a VA and a VB for
Yeah.
the sides.
Yeah.
So what I chose to do is I went off of VA. So the opposite of VA is 23.
Okay.
So that's what I did, is using the 23 in that equation instead of the 26.5. But even when I decided to do the 26.5, it gave me different answers, and I actually didn't know which one to choose.
Yeah.
So I went with the 23. But
Yeah. I don't know which one we're supposed to choose. Maybe 3.57. Maybe that'll help. I wonder how I would check that.
I don't know. According to, so this morning I actually had to go back and watch some of those introductory
Mm-hmm.
clips from the beginning of the lesson.
Yeah.
And the thing that's confusing me a little bit is so we have the 6.72,
Yeah.
and according to the lesson, the vectors of VA and VB should equal 6.72
Yeah.
without squaring.
I thought they were supposed to equal it when squaring, and then if you're not squaring, that squared should equal VA squared plus VB squared.
It was a weird introduction thing because they explained the squaring
Mm-hmm.
as right triangle stuff.
Yeah.
So, but
This isn't
I
even.
am actually with you on that
Yeah.
because we could pretty much say we have A and B we're finding, and we have C. So
Yeah.
why not use A squared plus B squared to verify?
I mean, that's. I don't know. I don't know what's right now. What do you think we should do?
Well, good question. I would almost want to go the route that you were saying with the a squared plus b squared. So let's use your the 6.72 cosine and sine of 26.5.
Okay.
Let's use that because either way, if doing it right, we should get basically the same answer, approximately.
Okay. That sounds good to me.
26.5. Do, 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 do. So 26.5 cosine times 6.72. So let's see. So you said with the cosine it's a 6.01.
Yeah.
6.01.
It's like 6.0139 something.
39. Okay.
And then with the sine, it was like 2.998, I think. I wrote down 2.99.
Okay, I got that too.
Okay.
And I'm guessing these are meter per second.
Yeah. I should write that down. Thanks.
Anytime. And what was the third part you made mention?
So
Because I didn't have that.
I did the v total equals the square root of the vx squared plus vy squared to get that total. And then, well, we should be able to set it to the 6.72 though, right?
That's what I was thinking.
And when you do it with those numbers, it doesn't equal that. I'm wondering if we do it with,
No, you do.
you do?
You do.
I got something wrong then. Just a second.
That was amazing. That just all of a sudden happened. I'm going to do it again just to make sure no hocus pocus happened.
Okay.
Squared plus 6.039 squared. Yeah, I got 6.72.
Okay. Apparently it did work. I wrote down something wrong then. Give me just a second to figure out what it was.
Go ahead.
Oh, okay. I did get it. I don't know how I.
I know
Oh,
that happens sometimes with calculators. You even clear it all the way and you'll still get.
yeah. Yeah. Okay. That's what I got. Oh, good. I was a little worried there. Okay. So for 4, what relative direction between them produces the resultant with the greatest magnitude? I said it would be parallel. And then for the minimum, it would be opposite. So like putting the tail to the tail so the heads face the opposite direction. And then, oh, I didn't do the maximum magnitude or the minimum magnitude. Wouldn't that be like 1 and 0 or something like that? What did you put for those? What was the
Um,
maximum and minimum?
so maximum and minimum. So the maximum, I just did other vectors because depending on what the size of the vectors are, you can have an infinite maximum.
So what did you say it was? Just infinity?
Yeah.
Okay.
I just said the sum
Okay.
because I wasn't sure what number to put for a maximum.
Let me see.
But for the minimum, it would have to be 0.
Okay, that's what I
Since,
thought.
yeah. And I did say the same direction, so your parallel wording works better for the maximum.
Okay.
So
I'm trying to look up something for the maximum that sounds better than just adding them together. Like, I feel like there's a more scientific way to, or
you're probably
mathematical.
right. Describe the maximum.
While I look for that, we can move on to the next one.
Okay.
This one, oh, you know what? I just realized what I did I don't think will work because it's not a right triangle. Because I did the c equals the square root of a squared plus b squared, but it's not a right triangle. So it shouldn't work.
Yeah.
So how did you...
What I did is first I wanted to find the angle of line A.
Mhm.
And so that's where, what did I exactly do again? Hold on. Oh, that's what I did. So there is the equation that theta equals arctangent of
Yeah.
Vy over Vx. So I
Okay.
did the 105 meters divided by 80, and I took the arctangent of that.
Oh. So that's 52.7.
That'd be 37.3 is what I got.
Arctan of 105 over 80.
I'll double check. 105 divided by 80. 52.7, is that what you said?
Yeah.
How did I get 37 point?
Did you actually put like 150 instead of 105? Because I did that earlier, but I did the problem wrong, so it doesn't matter.
Yeah, I must have.
Okay, so once we do that, where do we go from there?
So from there, now that we have theta, let's see. What was I was doing? Oh,
Oh,
so
the
we can go back to the equations of Vx or Vy equals V cosine theta. Since we don't have the V, we can,
substitute it in.
yeah, we can use the degree and divide one of the Vx or Vy by the cosine or sine theta.
So what are you using? So for the Vx and the Vy, you're using the 105 and the 80?
Right.
Okay. Makes sense. So which one did you use for Vx? And which one did you use for Vy? Would 105 be your Vy and 80 be your Vx?
That's what I assumed.
Okay.
Just going off of the a squared plus b squared thing and x becoming 4y.
Yeah. But shouldn't you get the same V each time, though? I mean, when you're using it in the normal equations, we use this. No, we don't. You're right. We don't. Okay.
It should equal the same v.
Yeah.
You are right. And I'm hoping that is the case.
This, my calculator won't let me take the inverse of cosine for 80.
You don't need to take the inverse of cosine. You do the theta cosine, and you take that number and put underneath the Vx. You only need to do the inverse when you don't have theta to find theta.
Oh, yeah. Okay, that makes sense. Oh, yeah, I just was skipping over parts. I always like to get one step ahead before where I actually am. And it causes
It's
a
all
lot of
good.
trouble with me. I think I've emailed Brother Johnson like 4 times and been like, wait, I'm stuck. And he's like, you're doing it right. Keep going.
I feel kind of bad I'm never able to participate in his office hours. I'm actually in South Korea right now.
Oh, yeah. A lot of the time it's like, so I'm working right now at home, so I don't have to go up for another semester, and then I can just graduate when I go up. But it's like I work every day. Well, not every day. I work Wednesday through Saturday, but I work late from early in the morning to late at night. So it's like I can't meet at all any of those days. So it's a bummer.
Oh, wow.
I can like late at night. So, all right. So once we got I got 132. Is that what you got?
Yes. What's fun is that is actually the answer I got beforehand, too,
Oh,
with 37.3.
oh really?
So maybe that's a different angle that I found.
Yeah, maybe. 37. I mean, if it works, it works, right?
Right? Okay. 132 is what I got.
Okay. Did you
So
ever hear back from the other person that was put in our group? Because I wrote on that like discussion board, but nobody ever wrote. And I emailed them, but I never heard back. So I feel a
I
little.
didn't even know someone joined the group until
Yeah,
you emailed me.
yeah. So I looked at it and there was like one other person, but I don't know. I feel bad. Okay, so
That's
6, did you do it the same way? Because I did it the same as the other one.
6. I tried to do it the best I could the same way. Um, what did I do there? So so it took me a little bit to realize that we actually had A and B.
Mm-hmm.
So I was actually trying to do it the long way and find all the angles. And
Oh, so how did you
so
doing it?
once I figured out there was A and B, I was able to take the tangent, arctangent to
A 40 over 30?
yes,
Okay, that makes sense. So literally the exact same way as we did the last one.
right.
Okay, that makes sense.
So we're in 5.
Okay. So
Um,
then your theta was 53.13.
my theta was 53.1.
Yeah. So then how did you get R on this one? Same way as, well, yeah, it should be the same way, right? Should
It
be the
should be the same way. I got about, okay, this is where it got confusing
mm-hmm.
because I thought of using Pythagorean theorem and that gave me 50
I
kilometers.
did Pythagorean theorem, but I don't think we can do it because it's not
Right.
right.
So,
That's what I did the first time, but it was after doing number 5 and realizing it wasn't a right triangle, and I looked down. This is also not a right triangle, so it shouldn't work.
crap, and that is probably right what you just said.
Okay.
2.13 cosine equals. I don't think I'm inputting this right.
So what are you doing in South Korea?
Um, I came to visit my dad who works on a military base
Okay.
and a little head in schoolwork.
Yeah.
Yeah.
Okay, let me see.
Got the answer beforehand. I'm not getting it now. It was like 41 point something is what it came out.
For x, I'm pretty x
For
is one where you do cosine, correct? Yeah. So for x, I got 49.99, so 50. I don't know if that's right. And then for vy, I got
well, mine keeps going to 66 when I try to divide 40 by cosine 53.13.
you got 66.
That's why it's not making sense.
Yeah, because I got 50 for both of them.
Then let's stick with yours
Okay.
because in the end, even with Pythagorean theorem, you get 50 as well.
Okay. Well, then my way was easier the first time. Okay. You know what we could do is we could take pictures of the work we've done. So like on this one where I have it written out already, we can take a picture. That way it's not like someone has to copy down all the right answers. That makes sense. And then we can email it to whoever wants to submit the document and they can just upload it.
That makes perfect.
Okay, so
Yeah.
did we finish 6?
Yes. I did. The last part is an explanation, and I'll summarize it because it's probably not the best wording. So the flight can be altered if there's enough force from the speed of wind coming from the north. With the mass of the plane and its speed, the wind could move the plane out of course little by little.
That makes sense. It's like that's one of the problems they give us in the book, so that makes sense.
Yeah. I was trying to remember because it was one of the last lessons in trig last semester was about stuff like this.
Yeah. My trig teacher last semester was not the best. She was like, people drop my class because I'm too chill, and I don't think I learned anything in that class. So it'll be a fun class for me. Okay, so let's run back to the beginning real quick, and so we can figure out who's taking a picture of what, and then submit it.
Okay.
Let's take a picture of your number 1 because I know I got that answer wrong, and I think you explained it. And then I think I did number 2, correct?
All right.
I do number 2 and 3. Are those ones where I had the answer?
Yes.
Okay, and then did you have 4?
I did have 4.
I just have parallel and then opposite was all I wrote on mine.
Okay. I'll take a picture of number 4.
Okay. And then we both have 5. I'll take a picture of, well, I just wrote down the exact same thing you wrote. Flight can be altered if one has enough force. One can move plane slowly out of its course. Okay, so do you want to take a picture of 6?
Yeah, I'll take a picture of 6.
Okay, and then now we're on 7, right?
Right.
Okay, so for 7, I did the equation for range, which is that R equals V naught squared sine 2 theta divided by gravity. So I did 7 equals 12 squared sine 2 theta divided by 9.8, which then gave me theta being 14.23 degrees. And then for B, I subtracted my 2 theta from 180. So I took away 28.45 from 180 and then divided that number by 2, which gave me 75.76. Does that Sound right?
Okay. So the first part sounded right. Go through the about last half.
Okay, so I got my theta. Well, my 2 theta ended up being 28.45. So I divided it by 2, and that gave me 14.23.
Okay.
And then to get my second angle, which should be the bigger of the 2 angles, I subtracted it from 180.
That would be correct.
And that gave me 75.76. I subtracted 2 theta, which was the 28.45 from 180. I'm wondering if I need to subtract just theta, which was the 14.23. Do you know?
If I remember right, you just subtract theta.
Okay, then that one would be different than what I put. So then it would be 180 minus 14.
Yeah.
So then it would be 165.77, which sounds better to me.
165.7
Yeah,
about.
165.8.
165.8 degrees.
I mean, that should make sense because it's like the opposite, right? You add 180 or you subtract from 180. Well, yeah, that should be right.
No, what you said is right. I'm trying to remember the degrees, but what you've done is correct.
Okay. Then I'm going to go fix my part C for the second one. For part C, I did T equals 2 V naught sin theta over G. And so for the smaller angle, I got 0.602 seconds. And then for the bigger one, let me redo it. I got 6.007 seconds, which
So you'll want to use the smaller one, the one with the smallest angle.
I did both. The one with the smallest angle, I got 0.602 seconds. So we're not even going to do the larger angle for C. We just do the smaller one.
Yeah, the smaller time.
Yeah.
Because I don't think he's going to want to check it at 165.8 degrees.
Yeah.
So,
Okay.
Because to answer the other part of part B, I
Mhm.
would not take way too long.
Yeah.
So it'd get to the same spot, but it wouldn't get there on time.
Yeah. That makes sense. Okay. So that's all I have for 7. And then you just got to 7, correct?
I just got to 7. I was trying to work on it before we got
Yeah.
here.
It's okay. I don't care. I don't care. So I have 9.
Okay.
Cover that. So it says if someone is riding in the back of a pickup truck and throws the softball straight backward, is it possible for the ball to fall straight down as viewed by a person standing at the side of the road? Under what conditions would this occur? How would the motion of the ball appear to the person who threw it? So I said that yes, it could appear straight down if the beginning of your throwing velocity matched how fast you were going in the truck, which is only possible if your truck is going slow, because then it'll go same down because you're starting and ending at the same speed type thing.
Yeah.
But for the person throwing it, it would look like it went in like a curved arc while it fell. I don't know if that's right though.
That would be right.
I mean, that part makes sense to me, but I'm not sure about the throwing
I
and the
just
velocities being the same. Like, I don't know how you would manage to do that. So I don't know how possible it actually is.
I don't think it's like completely realistic,
Yeah.
even though it's technically possible.
Okay. Okay.
That makes sense?
Yeah, that makes sense. So that's what I had for 9. Let me take a picture of.
Yeah.
of
That
my-
was perfect. I wish I could have written it like that.
Well, we can use my photo. It's fine. Okay. So for 8,
Yeah.
arrow is shot from a height of 1.5 meters toward a cliff of 4h. Is it shot with a velocity? Da, 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 da. Okay, so for the height of the cliff, I did y equals y naught plus v naught yt minus 1/2 gt squared. So that ended up being y equals 1.5 plus 30 sine 60 multiplied by 4 seconds minus 1/2 of 9.8 times 4 squared. And that gave me 27.02 meters. But it's only 2 sig figs, so it'll only be 27. Let me fix that.
Okay.
And then for B,
Above the hooray.
I did vy squared equals v naught y squared minus 2g multiplied by y minus y naught. And then I rearranged it so I had y equals y naught plus v naught squared sine 2 theta, or sine squared theta divided by 2g, which ended up being 1.5 plus 30 squared multiplied by sine 60 squared divided by 2 times 9.8.
Okay.
And that gave me 36 meters. Right, too many sixes.
Sounds about right.
And then I haven't done C yet, which is what is the arrow's impact speed just before hitting the cliff? So do you want to work on that one with me?
Yes.
Try to figure it out. These always take me so long to do.
When I was going through the tutorial, I was just amazed how many equations the one guy was using. Like,
I know, and I always have a hard time because they like rearrange them, but then they're not like, oh, I just rearranged this one equation. And then they like move on, and I'm like, where did that come from?
it's magic. It's black magic.
I don't do well with math. I have a hard time with like equations knowing like, okay, this is the equation I use here, and this is the one I use here. If they give me the equation, I'm good. If they don't, I'm in trouble.
I like it when they give the equation too.
Yeah, it makes it
I I took physics in high school, and kind of like your trig class where you didn't learn anything.
That's how mine was.
That was my exact physics class.
It
So I
was.
got an A in it, but I don't even know how.
Oh, I don't think I didn't do well in my high school physics class. I lived overseas and my teacher liked me, and so I would go and cry to him until he like let me retake everything, like after
Oh,
every test. And it was, I don't know, it was the worst though, because our teacher, they would hand back your test like in the order of who did the best to who did the worst. And I remember
yeah.
one time I was the one person who did the worst, and it was like the most humiliating experience of my life.
Oh, dang.
Yeah, it was, a real self-esteem builder.
uh,
Okay, so for C, I'm doing the Vx and Vy equal Vy cosine. Well, for Vx, I'm doing, so we need to know the Vy.
right.
So for that, I'm doing the Vy equals V naught y minus gt. So my V naught y will be the 30 sine 60 degrees. And then minus the 4 seconds multiplied by gravity, which is negative 9.8. And then that should
Right.
be so that gave me negative 13.2 meters per second.
Negative 13.
0.2.
Cool. I just realized I messed up on the height of the cliff.
It's always the worst when it's like in the middle of a problem and you have to go back and do the entire thing again.
Yeah. Luckily, the 1.5 meters doesn't mean too much since we're doing it straight from that point of reference.
And then I'm going to do the V equals the square root of Vy squared plus Vx squared. Let me go back and look at the problem. What does it say?
Trying to keep all these equations straight is kind of
I know, it's
challenging.
like a puzzle. I don't know how we're supposed to do it. I think that's how you calculate the final speed, though, because you're combining both of the velocities, correct? So you just need to know like the resultant vector, right?
Well, we need to know the speed of the arrow as it's about to hit the cliff at that point.
Yeah, but if you do the V equals the square root of Vy2 squared plus Vx squared, you're going to get it in meters per second. So it'll be a speed. I just don't know if it's the right speed.
Meters per second squared, so that's acceleration.
No, I think it's just meters per second.
Yeah, that's what speed is. But did you just say you got the answer or like part of it in
I'm
meters per second squared?
No, I didn't say meters per
No?
second.
Oh, my bad then.
I'm calculating. Well, I'm working on getting the final.
Okay. Velocity of 30 meters per second. Hands on top of it 4 seconds later. So what is this before?
So that gave me the V total equals 19.99. So 20 meters per second squared, or 20 meters per second, not squared, as the final velocity or final impact speed before hitting the cliff.
That actually sounds about right, or pretty close to it, because you have the 30 meters per second squared
Mm-hmm.
with the 9.8, well, 30 meters per second with the 9.8 meters per second squared pulling down
Yeah.
the arrow, and the arrow gets there in about 4 seconds.
Yeah. Yeah.
So about 20 should be correct because
Yeah.
it's still traveling.
Yeah. It sounds right to me. So I'm gonna say it's right, I guess.
Okay.
Okay, and then 10 is the last one, and I haven't worked on that one quite yet. I mean, I started doing part A, but
So we have part A and part B, correct?
yeah.
All right. So
So
an athlete crosses a 25-meter wide river by swimming perpendicular to the water current at a speed of 0.5 meters per second relative to the water.
yeah.
He reaches the opposite side at a distance of 40 meters downstream from his starting point. How fast is the water in the river flowing with respect to the ground? What is the speed of the swimmer with respect to a friend at rest on the ground? Okay. Let's see.
So he swam 25 meters, going 0.5 meters per second.
Mm-hmm. So if we
So,
draw a
yeah,
little triangle, we have the 25 meters, but he ended up swimming 40 meters downstream from where he started. So we can actually do the Pythagorean theorem and find that longer line, because we might need that later.
well, right now it's just asking for the first one, how fast is the swimmer, or how fast is the water in the river flowing with respect to the ground?
Back to the ground.
Well,
Okay.
it says the current, well, water current is 0.5 meters per second.
That's the swimmer.
Oh, that's the swimmer.
That's the swimmer.
Swimming perpendicular.
Yeah. So he's swimming at 0.5 meters per second, trying to cross that 25-meter gap, but ends 40 meters away from where he should have ended if he just made the whole 25 meters.
Yeah.
So he's trying to swim forward at that speed. And we have the water that pushed him down 40 more meters. So how fast is the water? Let's see. Range.
I'm gonna look at the textbook and see what it has to say.
Yeah. I have a feeling we are going to use the cosine and sine to find an angle. Or I hope I'm not overcomplicating things. I do that a lot.
That's my problem, is I always make it so complicated until I can't figure it out, and then I'll come back to it and I'm like, oh, it was a 2-step process. And I made it.
I hate those days. So not that one.
Okay, so I think we can do the Vx and the Vy with the cosine and sine. So our V would just be as 0.5 meters per second, right? Maybe.
So I would say so with the little triangle.
Yeah.
I'm trying to understand how to do this with water because we don't have gravity now. It's the water.
Yeah.
Um,
Um, when I tried doing the Vx equals V cosine theta,
yeah.
so I'm making the Vx 25 meters because it's 25 meters across. And then
Okay.
V is 0.5. So I divided my 25 by 0.5, which is 50. And then when I try to take the inverse cosine of 50, it's telling me an error, which I'm trying to think of what cosine 50 looks like on the unit circle. Why did
It shouldn't be
error?
error.
No.
50 cosine?
Inverse cosine.
Oh, inverse. Hold on.
Right? Because we don't have theta.
Let's see. So if it's error, let's see. So
Oh,
that's odd.
I think to find the speed of the water,
Yeah.
you can take how the distance of the river, so the 25, and divide it by how fast the swimmer is swimming just to get the seconds. And then you can divide the 40 meters by that second to figure out how fast it's going meter per second. Right?
That first part made sense. Explain the second part again, please.
Give me just a second. I'm trying to see if this is somewhat right.
That first part is right, though.
Okay,
It
so
would have taken him 50 seconds to cross the
yeah.
25.
And so then we know in that 50 seconds, he moved 40 meters down river. So if we divided that 40 by the 50 seconds, we could get how fast he went. Because speed is just the distance traveled over a period of time, right? So we know he traveled 40 meters and we know it took him 50 seconds. So that gives us 0.8 meters per second.
So we ended up. That answers B, doesn't it? Does that answer B? Because then he would have looked like he's swimming 0.8 meters per second, right?
Yeah.
So I think you just solved B.
I probably did. Okay, then how would we solve A?
0.8 meters per second. A, water. What was, here we are. I know I explained it in one of the tutorials, but it was going through all those um, equations. Let's see.
But we already know how fast the swimmer is going. We know he's going 0.5 meters per second. So then how would we just solved for it again but gotten a different number?
Because you solved for what the speed of the swimmer with respect to his friend who's on the ground.
Oh.
He may be swimming at 0.5 meters per second, trying to go in a straight line, but he starts going with the river, so to his friend, it looks like he's going slightly faster.
Yeah.
But how fast is the water? It's probably super simple.
Well, I think we're going to do, we have to find, well, for B, I thought, I think for B, we take the 0.5 and compare it to the 0.8 and then take the average of the two. And that's what the person standing on the ground would see. Because that would be the diagonal, that's like the resultant vector, you know?
Okay.
Whereas he's experiencing just the 25 meters across. So for him, he just swam 25 meters across. Like, you know, when they say like, oh, if you like drop, I think in the book it had like the people on the boat that was moving. And if you dropped, well, I don't know. Like if you drop something off the sail it looks straight down to you, but somebody watching from far away can see it falling in an arc. Because when you swim across
That,
the river, you would feel like you're just going straight, right? But the person
right.
watching you from ground would see that you're like slowly curving downstream.
So it would take the same amount of time.
Yeah.
It just looked different from
It
the
just looks different.
perspective.
Yeah.
Okay. That does make sense.
So then I think with that, you would do the V total equals, because we made a right triangle. So our V total
Right.
would equal the square root of the water speed squared plus the swimmer speed squared. And we know the swimmer is 0.5 meters per second.
Oh, so we can replace the 25 meters and the 40 meters with the 0.8 and
And the 0.5 that they gave.
5.
Yeah. And that will give us, that makes sense though, right? Like, I don't know how I would have calculated 0.8. Like, that would have to be the speed of the river, right? Because we already have the speed of the swimmer. And then when we do the V total, that would explain what it was looking like to the front on the ground. Maybe.
That would make that does make sense.
Okay, when I get that, I get 0.94 meters per second.
And to clarify, that the swimmer or the water?
That's for the person watching, which makes sense because it should be like almost, it should be faster than what the swimmer is actually going, which is 0.5, because the river will help pull him along and make it look like he's going faster.
True. So 0.9, you said 4?
Yeah.
0.94 meters per second. And that does make sense.
Yeah, I think I managed to convince myself through that one.
So what would the water be, since now we have a more concrete number for the swimmer? With that, we should be able to
I think the water is the 0.8 meters per second.
let's see.
Because we know that the swimmer can get across 25 meters in 0.5 seconds per meter. So when we calculate that, we're factoring out the meters entirely, and it's just giving us seconds. So it's just saying, like, from the time he began swimming to the time he stopped swimming, it was this point. And then we can compare the time to how far he drifted downstream. Because how fast he's swimming shouldn't affect how far downstream he's going to go. You know what I mean? Like, well, I mean, it will, but let me think.
Okay, I see what you're saying.
I'm trying to think of how to word it that makes sense.
I'm trying to figure out how mathematically we can solve that, because it makes perfect sense.
Yeah. Well, because
Even just that little bit would have pushed him
yeah.
after 25 meters. It would have pushed him about that far.
Mm-hmm.
Because if it was 1 meter per second instead of the 0.8, 50 seconds, it would try to have pushed him maybe about 60 meters. So
I think when we're trying to calculate how fast the water is going, we're kind of forgetting about the swimmer. Like, we're just using his speed to calculate the time between point A and point B. And that's the only thing we're using the swimmer's time for. And then we're using that time that we calculated to divide it by the 40 meters he went downstream.
that would give you a 0.8.
And that would give you how quickly the water is moving him. Because if you took that out, he would still get across the river in the 5 seconds, but he would get across at the exact same position. You know what I mean? Like he wouldn't be moving any farther. So how far downstream he goes should just be responsible. Like that's just the water's responsibility. So you can take the amount of time it took him to cross the river and then factor in how far down the water pulled him or the current pulled him, and then divide the distance by the time to give the speed of the water. Because like in this, he's just like a rubber ducky. Like we don't care about how like him crossing the river at all here. We just care about he started he started at 200 feet and now he's down at 240, right?
And that would give you your meters per second, because then you have 40 divided by 50, 40 meters divided by 50 seconds.
Yeah.
That'd give you your 0.8 meters per second.
I think we got this. I think we're just beating this one to death. But I can send you a photo of the work. Well, do you want me to submit it or do you want to submit it?
Do you feel comfortable in submitting it?
Yeah, that's fine. Just which pictures did we say that you would send again? 1 and 4, right?
So I have so I have 1. 2 is somewhat included, but submit your 2.
The only 2 that I don't really have written out completely are 1 and 4. So if you send me those, I can put them all together and submit it.
Okay. I have 1, 4, and 6.
Okay, send me that too.
Okay.
And then I'll
just to the BYUI.
Yeah, that's
email.
Fine.
Okay.
And then I will try to save this broadcast, I guess is what it's called, and then put that in the PDF, and we should be good to go.
Sounds great.
Okay. All right. I'll see you next week.
See you next week.
Bye.
You take care and have a wonderful week, okay?
You too. Good luck on the test.